Hey there guys, this is going to be the first video of your Unit 1 lesson, which is 1.1, Inverse Operations and One-Step Equations. So make sure you're following along with your packet or the PDF that is found on Canvas. Now first things first, an operation, so that's the first thing you're going to fill in, is a mathematical process that involves addition, subtraction, multiplication, or division. So those are your four main operations that you are familiar with. Now, along with operations, we have something called inverse operations. And we know inverse is just a synonym for opposite. So similarly there, inverse operations are something we use to undo the effects of a given operation. So they're typically the opposite of an operation. So inverse operation pairs are addition and subtraction. They're kind of opposites. Similarly, we have multiplication and division, which are inverse operations. These will undo the effects of each other. Now, we need inverse operations because they help us in solving equations when we're solving for x. If you can identify the operation being applied to a variable, you can undo it in order to isolate the variable or get the variable by itself. Now that's all well and good, but wait, don't forget, when you're using inverse operations, what you do to one side of the equation, you must do to the other. So an example here is if I have this problem here, and let's assume that I have a problem that tells me x minus 3 equals 9. Well, I can see the operation being applied to x is subtract 3. So I can say, okay, well, subtraction, my inverse operation is addition. So I'm going to cancel out this minus 3 with a plus 3. That's fine, but what you do to one side of the equation, you must do to the other. If I only add 3 to the left side, I have an unbalanced equation. So if I add 3 to the left side, I must also add 3 to the right side, so I have now a balanced equation. But let's do some examples. So we're going to identify the operation being applied to x as well as the inverse operation. So in our first example, we have x plus 3 equals 9. Well, I can see I'm adding 3 to x, so my operation is add 3. And the inverse operation of adding, or the opposite of adding 3, will be to subtract 3. So that's what I'm going to do here. I'm going to subtract 3, but remember, what you do to one side, I need to do to the other. What this means is what I do to the left side of the equal sign, I must do to the right side of the equal sign. Now notice here, 3 minus 3 is 0, which is exactly what we want. That's what we mean by they undo, because since now these cancel out, on the right side, all I'm left with is x, which is perfect. Now I have to simplify the right side, so 9 minus 3 is 6. Notice, since x is by itself, I can now find my answer. X equals 6. That's all you want to do when you're solving equations is solve for x or get x by itself. So here's another example. We have x minus 9 equals 10. In this case, we're starting with a subtract 9. And the opposite of subtracting is adding. So we're going to add 9 to both sides of the equal sign. So I'm going to add 9 to the left and to the right. Negative 9 plus 9 cancels out, which is perfect because I can get x by itself. 10 plus 9 is 19. X equals 19. Now, be very aware here, whenever you see a number next to a letter, that means to multiply. So 3x is the same thing as 3 times x. So the operation being applied to x is we are multiplying by 3. And the opposite of multiplying by 3 is dividing by 3. These are my inverse operation pairs that we can see up here. So I'm going to divide by 3 on both sides. Now when I divide by 3, I usually denote that by a fraction bar. Remember, a fraction bar is another way of writing divide. So I will write it like this to show that I'm dividing 3 on both sides. 3 divided by 3 cancels out, which leaves me with my x by itself. 12 divided by 3 is 4. X is by itself. X equals 4. Here, however, I have x over 2, but remember we said a division bar is the same thing as a fraction bar. So this is really x divided by 2. So we are dividing by 2, and the opposite of dividing by 2 is multiplying by 2. To show I'm multiplying by 2, I'm going to write a 2 with a dot, which is a symbol for multiplication. But remember, do it to both sides. Now these 2 cancels out. 2 divided by 2 cancels out, which leaves me with my x by itself. And then 30 times 2 is 60. Now here's some more examples. In this case, my variable is on the right side, which is fine. You'll solve it completely as normal. So you'll say, hey, what's happening to my variable? In this case, I am adding to my variable. In fact, I am adding 12. And the opposite of adding 12 is subtract 12. So I'm going to subtract 12 from the left and right side of the equal sign. 12 minus 12 cancels out. I'm still left with my variable by itself. And then I'll just perform this operation, 25 minus 12, hence 13. Notice I still have my variable by itself, 13 equals m. Now technically this is okay, but in preference in math, we prefer to write our answers as m equals 3. So we prefer to have the variable on the left and then the constant on the right. However, writing 13 equals m is the exact same thing as m equals 13. It's just preference. Now here, be very careful. Do not assume that my operation is adding because you see this plus sign here. Another way of thinking it is, hey, I have a negative sign here. And remember, negative signs are the same thing as subtraction. So the operation that's actually happening here is subtract 7. And the opposite of subtract 7 is add 7. Which will make sense because negative 7 plus 7 cancels out. So I'm left with b equals 31. Now, also remember when a parentheses is touching each other, this is kind of distribution. However, this is single distribution, which is just another word for multiplication. So this just means 5 times v. So we are multiplying by 5. And the opposite of multiplying by 5 is dividing by 5. So I'm going to divide by 5 on both sides. My 5's cancel out. And I am left with v equals 9. That is a very messy 9. There you go. v equals 9. Now, once again, this problem is very similar to this problem. It looks slightly different, but we still read this as 1 divided by 3. So what's actually going on here is division. So to get rid of that divide by 3, I know I'm going to multiply by 3. If I do that, my 3's cancel out. Now technically, you're left with a 1a, and then 9 times 3 is 27. But we know that 1a is the exact same thing as writing a by itself. It's called an implied one. So we've solved it at this point. A equals 27. Now here's a few more practice problems. At this point, I suggest you pause the video, try these on your own, and then come back to check your answers. But I will be working through some of these just to show you more examples. So for this case, we don't necessarily have to identify the operation and inverse operation, but we're still going to be doing that in our head. So the first one, 2k, well, I said that when a letter is switching a variable, that means to multiply. And the opposite of multiplying by 2 is dividing by 2. So I'm going to divide by 2 on both sides. My 2 divided by 2 will cancel out, or what really happens is 2 divided by 2 is just 1, so I'm left with 1k. 32 divided by 2 is 16. 1k equals 16. But like we said before, that is an implied one. 1k is the exact same thing as writing k by itself, so we solved this question. K equals 16. Going on to the next one, we have negative 8 plus a equals 17. Well, I can cancel out a minus 8 with a positive 8. But I want to keep my equation balanced. Since I added 8 to the left, I must add 8 to the right side of the equal sign. Negative 8 plus 8 is 0, so that completely cancels out. I have a equals 17 plus 8, which will give me 25. So A equals 25. X plus 19 equals 29. Well, in this case, since I'm adding 19, I'm going to subtract 19 from both sides, which leaves me with X equals 10. In this case, be very careful. Remember, this is not only 10 over 5, but I can also read it as t divided by 5. And the opposite of dividing by 5 is multiplying by 5. But what I do to one side, I do to the other. 5 divided by 5 is 1, which cancels out, which leaves me with t equals 20. So, as you can see, it's the same thing over and over again, as long as you can identify the operation as well as the inverse operation that will cancel out the original operation. It's mostly the same thing over and over again, just with different numbers. So we have a few more here, x minus 11. So the opposite of subtracting by 11 is adding by 11. And you get x equals 44. Now you might be saying, what if I'm not confident in my answer? What if I didn't know it was divide, or what if I didn't know it was multiply? So for example here, 45 equals b times 15. Well, remember this dot also means multiply. The opposite of multiplying is dividing. I'm going to divide by 15 by both sides. And I get v equals 3. Remember, if the variable is on the right side of the equation, that's fine. You solve it the exact same way. Now, typically when we write our answers, we prefer to write the variable on the left and then our answer. But 3 equals b is the exact same thing as b equals 3. They mean the exact same thing. It's just preference once again. So from here on out, you're going to keep going. I'm going to subtract by 25 on both sides, which will leave me with x equals 20. Now, if you're ever unsure about your answers, you can always check your answer. So if I know x equals 20, if I plug it back into my equation, I can check to see if it gives me the correct thing. So if I do 25 plus the 20 that I found, does that give me 45? Well, 25 plus 20 is 45. Since both sides of the equal sign are equal, that's true. So you can always check your answers when you're doing, or when you're solving for x. Just plug back the x that you found into the original equation. Now here we have 1/5 w equals 10, which we can also read as 1 divided by 5, and the opposite of dividing by 5 is multiplying by 5. So we're left with 1w equals 50, which we know 1w is the exact same thing as just w. W equals 50. Going on to our last row of problems, we're going to add 9 to both sides, and this is minus 9. And that is going to give me a on the right side, which once again, if it's on the right, just solve it like normal. Negative 10 plus 9 is negative 1. So this is also testing your integers problem, so integers will still be popping up over and over again in Algebra 1. So be careful there. Negative 10 plus 9 is not 19. It is negative 1 because the large number is negative. N over 6, which can be written as n divided by 6, will be canceled out by multiplying by 6. So I get n equals 18. And if I was ever unsure, I can always check my answer. If I plug in the 18, where there used to be an n, so n over 16, if I am assuming n equals 18, I'm going to write 18 over 6, and then ask myself, does this equal 3? Well, 18, remember this means divide. 18 divided by 6 is 3. Since both sides of the equal signs are equal, or this gives me a true statement, then yes, n equals 18. So once again, if you ever want to check your answers, just plug back whatever you solved for back into the original equation. Now this case, I am multiplying b by negative 6. The opposite of multiplying is dividing. Since I'm multiplying by a negative 6, I need to divide by a negative 6. So that's just going to leave me with v equals, remember, negative divided by negative is positive, positive 5. And then I can check Positive 5 times negative 6 is indeed negative 30. The final one, I am adding by 6, so I am going to subtract by 6 on both sides. And once again, this is an integer problem. 4 minus 6 is negative 2. So make sure you know how to add and subtract positive and negative numbers. So that's it for the notes. Now you have practice problems to try on your own for the assignment for this lesson. If you have any questions, don't forget to sign up for tutoring or email your teacher. Otherwise, have a nice day.